Hello. In this lecture, we are discussing various timer modes. In earlier our lectures, we have seen what is the hardware and what are the timers. Here we will see the actual programming of the timers in 8051. In Intel 8051, there are two 16-bit timer registers. These registers are known as timer 0 and timer 1. The timer register can be used in two modes, that is mode are timer mode and counter mode. The only difference between these two modes is source of incrementing the timer register. The timer mode. The timer means when it is using internal clock for counting the pulse, then it is a timer. In the timer mode, the internal machine cycle are counted. So this register is incremented in each machine cycle. So when the clock frequency is to say 12 megahertz, then the timer register is incremented in each millisecond. In this mode, it ignores the external timer input pin. And counter mode. In the counter mode, the external event are counted. In this mode, the timer register is incremented for each 1 to 0 transmission of the external input pin. This type of transition is treated as event. The external input pins are sampled once in each machine cycle, and to determine the 1 or 0 transition, another machine cycle will be needed. So in this mode, at least 2 machine cycles are needed. When the frequency is say 12 megahertz, then the maximum count frequency will be 12 megahertz divided by 24 because you need 2 machine cycles. So that will be equal to 500 kilohertz. So for the event counting, the time duration is 2 milliseconds. Now we have seen there is a timer and counter the register. The registers can be used as either timer or counter. Then what is the difference between timer and counter? The only difference is the source of the pulses or event being counted. In case of timer, as we have seen this in hardware, there is a machine clock, and in timer mode it counts the machine cycles and it works as a timer. In that case, the external interrupt pin is disabled, because even if there is an external interrupt, it will not count that, it will not take care of that external interrupt, and it will only count the internal pulses of the microcontroller, internal machine clock. Whereas in case of counter, you have to count the events happening outside the microcontroller. That's why the gate pulse has to set, gate bit of the T mode has to be set to 1, so that it will take care of the external interrupts, and it will, when the interrupts occur, that means when it is high to low, that is the edge is going from high to low, that time there will be that it will increment the timer. It will increment the timer or counter register, and it will count that event. So this is how the timer and counter works. These timers can be used for various timing and counting applications in embedded systems. They can operate in different modes to suit a specific requirement. Timer modes. We have seen that timer and mode, there are different modes of operation. What are the modes? We have already seen in detail in earlier lectures. But this is the 8051 timer counter can operate in 4 different modes. That is mode 1, first is mode 0, that is 13-bit timer. Then mode 1 is 16-bit timer. Mode 2 is 8-bit auto reload and lastly mode 3 is split timer mode. We will see all these modes in detail in our subsequent slides. The serial port is used for serial communication in mode 1 and 3. The timer 1 is used for generating the baud rate. When you are using a serial communication, that time timer mode 1 and mode 3 will be used for counting the external events in serial communication, and that we need a time to generate a baud rate. Baud rate means what? It has to match the bits coming in and the speed of the machine, so that there will be a perfect data communication. If, for example, suppose you are dictating to someone, you are dictating some paragraph. So in that case, what happens? You have to dictate in a speed such that his writing speed and your dictating speed will be matched. Suppose if you are telling very fast, the person who is writing will not be able to take it down what you are telling. Otherwise, if you are telling very slow, the writer is able to write fast, but you are telling in very slow mode. That will unnecessarily waste the time. There will be a gap, so that writing will not be perfect. So there has to be a perfect match between the writing and your dictation. So this is called a baud rate. Your telling rate and the writing rate should be matched. This is a example what can be given to clearly what is a baud rate. Baud rate means the actual machine speed and the data communication speed has to match. So only timer 0 is available for timer or counter during serial port, during serial communication, during serial counting or timing. Okay. Timer 0 and timer 1 registers. What are the registers? Now, timer 1 0 register. This is a 16-bit register of timer 0, is accessed as low and high bytes. The low byte register is called TL0, timer 0 low byte, and the higher byte register is called as TH0, that is timer 0 higher byte. These registers can be accessed like any other register. For example, the instruction move TL0 #4H. This moves the value 4 into the lower byte of timer 0. The 4 will be moved to TL0 of timer 0, that is low byte of timer 0. This is what is a timer 0 register. This is a timer 0 low byte, which is 8 bit. This is timer 0 high byte, which is again 8 byte. This is the initial value. This is bit 0, bit 1, bit 2. This is a timer 0 register. Timer 1 register is also similar. There is no much difference. The 16-bit register of timer 1 is accessed as low and high byte, same as timer 0. The low byte register is called TL1, timer 1 low byte, and the high byte register is called as TH1, that is timer 1 high byte. The registers can be accessed like any other register. For example, instruction move TL1 4H. This moves 4H to the low byte of timer 1. This is what? This is lower byte of timer 1 and this is a higher byte of timer 1. This is 8 byte, this is 8 byte. That's it. The timer 1 and timer 2 are, these registers are 16-bit registers. Now timer T mode and T con registers. After having seen what is the timer register, now we will see the T mod and T con register, which are invariably used for programming the timer and counter. This plays very important role during our timer and counter operation. Introduction. Two registers TMOD and TCON are closely connected to this timer and control its operation. TMOD register, that is timer mode. The TMOD register selects the operational mode of the timer T0 and timer T1. As seen in the figure below, the low 4 bits, bit 0 to bit 3, refer to the timer 0, while the high 4 bits from bit 4 to bit 7 refer to the timer 1. We have seen there are 4 different modes of timer, and each timer can be used in all these 4 modes. So how this will be selected? So there are 4 operational modes, and each of these is described herein. See, this is what is the T mode register. The 1, 2, 3, 4, the lower 4 bits are reserved for timer 0, and 5, 6, 7 and 8, these are for timer 1. These two are used for selecting the timer mode, and C/T0 is used for either to work as a timer or a counter, and gate, this is to start this gate. When it is set to 1, it will take care of external interrupt, and when gate is set to 0, it will not depend on the external interrupt output. Now what are the bits, we will see in our subsequent slide. The same thing is for timer 0. These 2 bits are for timer 0, and this is for timer these 2 bits are for timer 1, and this is for timer 0. The same thing. If it is set to 1, this is set to 1, then timer 0 will act as a counter, and if it is set to 0, the timer 0, if this set is set to 1, the timer 0 will act as counter, and if it is set to 0, then it will act as a timer 0. These are the various modes. When we have seen that first 2 bits, bit number 0, 1 and 5, 6, these are the bit selection modes. X means either T0 or T1 M0, and T0 or 1 M1. Then what are the modes? If both are 0, mode 1 will be selected, mode 0 will be selected. That means this is a 13-bit timer mode. That is, timer high bit of the timer will be having 8 bits, and lower bit will be having 5 bits. And when this is 0 and 1, it will work in timer mode 1. That means it will work as a 16-bit timer mode. When M0 is 1 and M1 is when M0 is 1 and M1 is 0, it will work in mode 2. That means it is 8-bit auto reload timer mode. What is auto reload? That we will see subsequently. And both are 1, that times it will work as a mode 3. 2 8-bit timer mode or split timer mode, which will be working independently. To configure the timer 0 as 16-bit event counter and timer 1 as 8-bit auto load counter, we can use the bit pattern. This is 0 0 1 0 0 1 0 1. That means this is we are talking of timer 0. So these bits are for timer 0. This 0 1, that means since is in mode timer mode 0. 16-bit event, that is 16-bit event means is a timer mode 1. So this is timer mode 1, and this is a timer. You want to use as a timer, that's why you are setting it to 1, and this bit is irrespective of the internal output. interrupt. It is equal to 25H. That means this one 4, this is 5, and this is 0, and this is 2. This bit is 2 and this is 5. So it is 25 hexadecimal. If we want to program the T mode register with this bit pattern, we can use the instruction. Now we are decided in what mode the timers are to required, and we have created the digit. Now this digit has to pass on the timer mode register. So how we'll do that? By giving the instruction move T mode #25. That means immediate addressing mode. This is called immediate addressing mode. So you are moving a 25 on the T mode register and setting the timer 0 in mode 0, mode 1. It is 16-bit timer and irrespective of external interrupt, and it is a timer mode. The above instruction is executed, then the timer counter will be controlled by the software. To configure the system as a hardware control mode, then the gate bit will be 1. If you are setting gate bit to 1, so it will depend on the external source. Now here earlier what we had done, it will not depend on the external interrupt. Now here we want to depend these timers on the external interrupts. That's why you are enabling this setting this gate pulses to 1, and this is the timer modes we are keeping same as earlier. So this will change the word, and that will become as AD. A means this is A, 2 plus 8, 10, and D means this is 8 for 4, 12 and 13. 13 means D. So ADH, and then this will be moved to the T mode to change the mode. If it has to be make as a hardware dependent and mode 1, then you will move AD to the T mode register. The gate bit will be high, then the timer or counter is in mode 0 or 2. Example. This is now TCON. We have seen T mode register, the timer mode register. Now we will see what is timer configuration register, timer control register, how the timer will be controls. The timer control or TCON register is used to start or stop the timer of 8051 microcontroller. It also contains bit to indicate if the timer has overflowed. The TCON special function register also contains the interrupt related bits. See, this is how is the TCON, T timer control register. These 4 bits are for 1, 2, 3, 4 are for timer 0 and up. This is 0 is for timer 0 and all 1 are for timer 1. This is IT0, this is interrupt of 0, then IE interrupt enable of 0, then IT1 is the interrupt of timer 1, then IE0 is the interrupt enable of timer 1. This is TR0 means timer 0 start stop, TF0 means timer 0 overflow, TR1 means timer 1 start stop, and TF1 means timer 1 overflow. The following table gives the description of each bit in the TCON special function register. This is the table. Now we have seen what are different pins, the bits of the TCON register. Now we will see each one by one. When this is bit 7, that is the MSB, that is TF1, that is timer overflow flag of timer 1. It is set to 1. What happens when the interrupt of the timer 1 is going from high to low? When the timer occurs, then this TF1 will be set. That means it will show that the interrupt has occurred and it will jump to the address 001BH where the interrupt service routine has to be written. When this flag is set to 1, this will be set when there is a interrupt or there is a overflow. If there is a, you are using timer, if there is a timer overflow, it is set when the timer 1 overflows. When timer 1 flow is setting to 0, from FF it is going to 0, this will be set to 1. That means the interrupt has occurred and it will directly jump to the address 001BH and it will attend the routine connected to written in there. Then TR1, timer 1 run control bit. To enable the timer or counter, it is set to 1 and it is clear to stop the timer 1. Similarly, TF0 will be set to 1 if timer 0 overflows, and when it is set, the program counter will run to interrupt vector 000BH. And similarly, what we have seen is TR1, this is TR0 is the timer 0 on off. IE1, internal interrupt 1H flag. This will get set. What happens when the interrupt pin 1, that is pin number 3.3, goes from high to low. When it is going from high to low, that means some interrupt has occurred and that time this will set to 1. And IT1, and when the IE1 is set, it goes high, it will jump to the ISR 0013H at this address and the routine written there will be executed. The IT1, the external interrupt 1 type control bit. This bit will decide whether you want the interrupt to be a level control or edge control. If it is set to 1, then it will operate on falling edge, and if it is 0, the interrupt 1 occurs when there is low to low level. That means it decides whether you want to make it as a level control or level trigger or edge triggered. Similarly, IE0 is the interrupt 0 edge flag. This was for timer 1 and this is the same thing for timer 0. It is set to 1 when high to low. When the pin number P3.2 go from high to low, this IE0 will become 1. And again here, if you want to decide whether it's the pin number should be pin number 3.2 should be edge triggered or level triggered, to decide that you have to set this bit either 1 or 0. Now coming to this ISR and the addresses of interrupt. And earlier I had given one example. Suppose you are sitting for your study, that is you are running your main program, and when a doorbell rings, you have to stop your study and go to the door to open the door. Maybe a service person, a courier person might have come there. You have to take a courier and come back to your study and continue the study. Then after some time, suppose a telephone bell rings. Then you will go to the telephone and pick up the receiver, speak there, keep the receiver back, you will finish your telephone conversation and will come back to study. Like that, now see, there are two different interrupts at two different locations. Okay, so when the doorbell rang, you went to the door. That means the TF1, the timer, or when the timer 1 overflow occurs, then it will jump to this address, and if timer 0 overflows, then it will jump to this address. That means suppose this is a door 1, this is door 2. When door 2 bell rings, then the ISR will go there. ISR means the routine written there. Routine means what here? ISR means what? As I told, when the doorbell rings, you went to the door, and what activity you are doing at the door? You are taking the courier and coming back. This is the interrupt service routine at door. Similarly, interrupt service routine at telephone call is what? When a telephone rang, you went to the telephone, you didn't go to the door. So this is another interrupt. When this interrupt occurs, i.e. that is interrupt enable, that is IT1 has gone from high to low, that time this IE1 become 1, then it will jump the program counter to 0013. That means suppose here a telephone has rang and it has told ki this that means this interruption has come. This bell has rung, the interrupt has occurred in your study. Now you went to the telephone. This is a telephone address and you attend the ISR, means you are attending the phone call. Okay, this is ISR. So this is what is ISR, the interrupt service routine at that particular interrupt location and the address of that particular interrupt location. So this is how the overflow, interrupt, timer on off, these are the various bits we have seen of the timer control, SFR. Initializing a timer. How we should initialize the timer? Decide the timer mode. Consider a 16-bit timer that runs continuously and is independent of any external pin. Suppose we have to program a timer like this. We want to make a 16-bit timer that continuously runs and independent of the external pins. This is a situation. This is a situation we want to design a timer for this. Then what we will do? Initialize timer T mode SFR. Use a lowest 4-bit of T mode and consider timer 0. Now we will consider a timer 0 in 16-bit independent of external pins. So this is the condition. Now what we will do? Keep the 2 bits get 0 and CT0 as 0. Because why you are making it 0? Because you don't want to depend on the external pins. That's why you are setting get to 0 and CT to 0. Why it is 0? Because you want to use as an external pin. You want to continuously count. You are doing the counter. You want to make as a counter, 16-bit counter you want to make. That's why you are setting it to 0. And why get it 0? Because you don't want to depend on the external pins. Since we want to timer to be independent of external pins. That's why get is made to 0. A 16-bit mode is a timer mode 1. Clear T0 M1 and set T0 M0. That means you set 01. That means you are now setting it to mode 01. The only bit to turn on is bit 02 of MT mode. Now execute the following instruction. Now you are moving. See, you are keeping all zeros. And as we have seen, get it 0. Then timer counter is 0 because you want to use the counter. And you want only to work as a mode 1. That means M0 and M1 has to be set to 01. So this is, if you move 01 to T mode, then what will happen? A timer 0 will run as a 16-bit counter irrespective of external pins. This is clear. When you are moving timer mode, or I can try to write here. Okay, this is what will happen. Now timer 0 is in 16-bit timer mode, but the timer is not running. The timer is not running. Why? To start the timer in running mode, set the TR0 bit by executing the following instruction. Now set TR0. Now time. Now time you when you set TR0 to 1, the timer will start running in a 16-volt timer mode. Now the timer 0 will immediately start counting, being incremented once every machine cycle. This is being now work as a timer. Reading a timer. A 16-bit timer can be read in two ways. Either read the actual value of the timer as a 16-bit number, or you detect when the timer has overflow. You can either read it timer register, or you will read it by timer overflow. That means when you use the timer overflow, obviously it will be all 0. It will be flowing from FFF to 000. Detecting timer overflow. How the timer overflow will be detected? When a timer overflow flows from its high value to 0, the microcontroller automatically sets the TFX, that is TF0 or TF1 bit in the TCON register. Set means it becomes 1. So instead of checking the exact value of the timer, the TFX bit can be checked whether all has become 0. If TF0 is set, then the timer 0 has overflown, and if TF1 is set, then the timer 1 has overflowed. That means overflown means now it has become 0. From its high value it has gone to 0. Now timer 0 mode. Now what is timer 0 mode? Detail. The timer 0 mode operation is the 8-bit timer or counter with the 5-bit prescaler. So it is a 13-bit timer counter. It uses 5 bits of TL0 or TL1 and all 8 bits of TH0 or TH1. That means it is using all 8 bits of TH and 5 bits of TL. Thus it makes it 13-bit. And the 5 bits are used as a prescaler. See, this is how will be the structure. This is it. Say, suppose we are considering a timer 1, and this will increment the input. When the TH1 goes high, the timer overflow flag of timer 1 will set, causes the timer 1 interrupt if the conditions are met. This we are showing in case of timer 1. These are the 5 bits of low byte and all 8 bits of high bytes of timer 1. This and TF1 will be set to high when all goes to this overflows, when it goes from high to 0. In this example, the timer 1 is selected. In this case, every 32, that is 25 event for the counter operates or at 32 machine cycles for timer operation. The TH1 register will be incremented by 1. TH1 will be incremented. When the TH1 overflows, that is it goes from FFF to 0, then the TF1, that is timer overflow of TCON register will be high and it stop timer counter. When it becomes 1, the timer will automatically stop. Timer or counter, it will automatically stop. Now we will write a program for that. Move tmod 00, because we want to make timer 0 as mode 0 timer. Now move TH1 F0 hexadecimal. Move IE88H. This is basically the IE is the interrupt control register, interrupt enable register. What is interrupt enable register? We'll study during our interrupt. At present, you don't worry about this 88 and MOVEI. Set TR1, that means start timer 1. In the above program, timer 1 is configured as timer mode 0. In this case, gate is set to 0. That means you will not be worrying about the external pins. Then the TH1 will be loaded with the F0. Then enable the timer 1 interrupt. At last, set the TR1 of TCON registered and start the timer. Set means make TR1 equal to 1 and timer 1 will start running. Timer mode 0 or T0 is one of the 4 timer or counter modes available in 805 microcontroller. The timer mode 0 is a basic timer mode that can be configured to perform various timing and counting tasks. In this mode, timer 0, that is T0, operates as a 13-bit timer, meaning it counts from 0 to 8191, that is 2 raised to 13 minus 1. Up to that it can count because it is 13. Timer mode 0 in detail. Timer registers. In timer mode 0, timer 0, that is T0, uses 2 8-bit register, TL0, that is timer 0 low byte, and TH0, timer 0 high byte, to form a 13-bit. TL0, this is the lower 8-bit of timer 0, and TH0, this is the upper 5 bits of timer 0. In timer mode 0, only bits 4 to 7 of TH0 are used, while bits 0 to 3 are reserved. Those are not used. Now operation, how it operates? In timer mode 0, timer 0 is configured as a 13-bit timer or counter. The timer continuously counts up from 0 to 8119, that is 000 to 1FFF hexadecimal, and then rolls over back to 0. The timer counts at a rate determined by the clock source. How the counting will be done? That will be determined by the frequency or the clock cycles. Now clock source. Now which clock source it will use? The clock source for the timer 0 in the timer mode 0 can be selected from 3 of the options. It can be external input, that is T0 pin. You can connect an external clock signal to pin T0 pin of 805 microcontroller. The timer will count each rising or falling edge of the signal depending on the T0 pin configuration. You can use a external circuit connected to T0 pin for counting the external events. This is what one clock source will be available. Otherwise, second is the system clock. We have seen in earlier figure there is a crystal frequency and there is an internal clock. That internal clock, the microcontroller system clock, can be used as a clock source. In this case, the timer counts at a rate of 1/12 of the oscillator frequency or a crystal frequency if a crystal oscillator is used. We have seen in the circuit that the crystal was connected to the one oscillator circuit. This you can use. Otherwise, you can use a external oscillator or quartz crystal. If you have an external oscillator or a quartz crystal connected to the microcontroller, you can use it as a clock source for timer 0 or 1. The frequency is divided appropriately to generate the timer clock. That will be divided internally by the internal clock. Now overflow and interrupts. Now what are the overflow and interrupts in case of timer 0? When the timer 0 overflows, that is, overflows means reaches to maximum to 0 level, that is maximum level, that is when it reaches to 8191, is set a flag called TF0. When it is overflown, when it is going reaching to its maximum value, TF0, timer 0 overflow flag will be set to 1. This overflow can also trigger an interrupt if the corresponding interrupt enable bit is ET0 is set. In our IE register, if the interrupt enable is set for the timer 0, and when this overflow occurs, then the program will jump to the address where for the timer 0 interrupt. As we have already seen in earlier our slide, there is a certain address and it will attend the interrupt service routine written there. This happens if this interrupt is enabled. Program execution can jump to the interrupt service routine ISR to handle the overflow event to or perform other task. This is what is overflow. Now programming timer mode 0. Now how to program timer mode? To use a timer mode 0 in 8051 microcontroller, you typically follow these steps. What are these steps? First, configure the timer mode control register TMOD. First you have to configure the TMOD register to specify that the timer 0 is in mode 0. Set the initial value for TL0 and TH0 as needed. We have to set the mode. We have already discussed many times how the mode is set. So timer 0, the bits of timer 0 are to be set to 00 to work is at timer 0. Then you want to load the amount or load the figure for generating a delay or to make a timer a suitable value of TL0 and TH0 as you need. Then start timer 0 by setting the TR0, that is timer run 0, timer 0 run to set to 1. If you set this to 1, then only start timer will run. Optionally, enable the timer overflow interrupt by setting the ET0, enable timer 0 interrupt bit. Otherwise, you can do this by, if this interrupt occurs, then timer 0 will start. This can be done as option. This we will study in detail when we will be learning interrupts. And lastly, in your program, you can check the TF0 flag to detect when timer 0 overflows. And last one, if the interrupts are enabled, the microcontroller can jump to an interrupt service routine to handle the overflow event. If the interrupt is enabled, then the interrupt has to be attended. What is interrupt? Interrupt is basically a priority program during your main program. If you are running a main program and interrupt occurs, you have to give a priority. Okay, what is the priority? That means suppose you are doing the study and a courier person comes on your door. You had to stop your study and go to the door to attend the courier person. The courier person cannot wait till you finish your study. Okay, this is similar to that. The interrupt cannot wait till you finish your program. It has to be attended on the top priority, so that it will immediately jump to the address where the interrupt has occurred and it will attend the interrupt service routine written there, and it will come back to main program. Now timer mode 1. Now we'll see what is the timer mode 1. The mode 1 operation is the 16-bit timer or a counter. In the following diagram, we are using a mode 1 for timer 0. Now we will see a diagram where a timer 0 is used as a mode 1. So this is a timer 0 and it will use both TL0 and TH0 to make it as a 16-bit timer. And when it overflows, the TF0 is 8-bit register, and when it overflows, it will give the interrupt signal. and if you are enable the interrupt, then it will go to jump to this interrupt vector to attend at that ISR for the interrupt due to the timer 0 overflow. That interrupt timer 0 overflow means it may be in any mode. When the TF0 has overflown, there is an interrupt. It may be in any mode, maybe mode 0, mode 1, mode 2, mode 3. In this case, every event for the counter operation or machine cycle for the timer operation, the TH0 and TL0 register pair will be incremented by 1. If it is using a timer, every pulse will increase the timer to this register to 1. Or if you are counting the external pulse, for every event occurring, the registers TH0 and TL0 will be incremented to 1. When the register pair overflows, from FF to 00, then the TF0 of the TCON register will high, and it stops the timer and counter. It stops the timer and it will jump to the ISR to attend the interrupt service routine. So, for an example, we can say that if the TH0 TL0 register pair is holding F0 hexadecimal and it is in a timer mode, then TF0 will be high after 10 hexadecimal, that is 16 machine cycle. It will be high. When the clock frequency is say 12 MHz, then the following instruction generates an interrupt 16 microsecond after timer 0 starts running. If you are setting FF and F0 in the registers, and if the clock frequency is 12 MHz, then after timer 0 will start running. After it 16 microsecond, it will generate an interrupt. So if you want to delay of 16 microseconds and if you are having a 12 MHz clock, then you load the TH0 and TL1 by F0. So this gives you 16 microsecond delay. This is how you can work out how the timing and what figure has to be loaded into the TH0 and THL, or TH and TL of the timer. Maybe timer 0 and timer 1 you can use, and this is how the timing will be calculated depending on your clock frequency and your delay required. Now move T mode 01. You are using timer 0 as a mode 1. So you have moved 01 to T mode register. Then move TL0 0F. Then move TH0 0FF. That what we are saying, because we want to generate a 16 microsecond delay. Now move IE82H. This is interrupt enable. We will discuss this during our studies of interrupts. Now set bit TR0. Set bit means start timer 0. In the above program, the timer 0 is configured as timer mode 1, 01. This is a low bit of T mode, lowest least LSB1 and LSB2. These two bits is setting timer 0 in mode 0. Then you are loading, then gate is set to 0 because it will work independent of the external pin. Then the TL0 will be loaded with F0 hexadecimal and TH0 is loaded with FF hexadecimal. Then enable a timer interrupt 0. By this interrupt instruction, you are enabling the timer 0 interruption. At last, set the TR0 of TCON register and start the timer. To start the timer, you are setting TR0 to 1. In timer mode 1, both timer 0 T0 and timer 1 T1 operate in 16-bit time or counter. Both the timers, either timer 0 or timer 1, can be used as a 16-bit register in T mode, mode 1. This mode offers a 16-bit resolution, allowing for a wide range of timing and counting application. If you want to count large number, then you can go for mode 1, where you will get 65,000 events you can count. Let us explore timer 1 mode of 8051 microcontroller in detail. Now, timer 1, timer or counter operation. In timer mode 1, both timer 0, that is T0, and timer 1, T1, are 16-bit register. Each timer can be independently count from 0 to 65,535, that is 2 raised to 16 minus 1 events. External events or pulses it can count. The timer operate independently and can be used for separate tasks or synchronize it if needed. These two timers can be independently used, or it can be synchronized also if required. The timer 0 uses the TL0, that is timer 0 low byte, and TH0, that is timer 0 high byte register, while timer 1 uses TL1, that is timer 1 lower byte, and TH1, that is timer 1 high bytes registers to store a 16-bit data. Timer mode selection. To select the timer mode 1 in 8051 microcontroller, you need to configure the timer mode control register, that is T mode register you have to configure. T mode is an 8-bit register and is at bit 0 and 1, that is T0M0 and T0M1, control timer 0's mode, and while bit 2 and 3, TM10 and T1M1, control the timer 1 mode. For timer mode 1, set T0M0, T0M1, T1M0 and T1M1 to 1, 0, 1 and 0. That means by setting these two, you are setting to the modes of the timers. How to set the modes we have already seen while discussing the T mode register. Clock source. As discussed earlier, you can use either of the clock modes. A timer mode, one like other timer modes, can use various clock sources, that is an external clock signal can be provided to the timers, or the microcontroller's crystal oscillator frequency can be divided into generate the time clock, or the timer can use a system clock divided by 12 as a clock source. These are the clock source which we have already discussed. Either maybe it may either external pulses, or it can be a system clock or a crystal oscillator to generate the clock. Now, overflow flag. When either timer 0 or timer 1 reaches its maximum value, that is 65,535, it generates a overflow flag which is specific to each timer. That means if the timer 0 reaches to 65,535, then TF1 flag, when timer 0 is reaching to value 65,535, TF0 will be set to 1, and if timer 1 is reaching to its value 65,535, then TF1, timer 1 overflow flag, will be set. The overflow flag for timer 0 is TF0, timer 0 overflow flag, and for timer 1 it is TF1, timer 1 overflow flag. These flags are set, logic 1, when an overflow occurs and must be cleared to set to 0 by this software. To restart the timer, this has to be cleared to start the timer again. Otherwise, the timer will not run, because it will treat that as interrupt is still existing. Now, interrupts. Now, what is interrupt? When an enable, you can enable or disable timer 0 and timer 1 interrupt in the timer mode 1. And how this will be enabled? That will be enabled in our IE register, interrupt enable register. Will if you are setting doing a proper setting in IE register, then this timer interrupt will be enabled. You can enable or disable timer 0 and timer 1 interrupts in the timer mode 1. If enabled, the microcontroller can generate a separate interrupt request on for INT0 and INT1 when TF0 and TF1 are set. When overflow occurs, then it will generate an interrupt 0 request and interrupt 1 request if their interrupts are enabled. If TF0 overflows, INT0 will be activated, and if TF1 is overflowed, INT1 will be activated. When an interrupt occurs, the microcontroller can jump to the predefined interrupt service routine ISR to handle the overflow event or perform other tasks. I have already explained what is interrupt service routine, what is the interrupt service vector, by giving the example of telephone and doorbell. When a doorbell rings, you will go to the door, take the courier. This is the interrupt service at the event. When event of doorbell is occur, that is interrupt has occurred at that point, the address is door, you have taken the service. This is one event, one that is address and the ISR for that door. And for telephone, this is another event, other interrupt. A telephone rang, you went to the telephone, you attended telephone, you went to the telephone, that is a interrupt vector for telephone. You attended the telephone, that is the interrupt service routine for the telephone call. This is how the similarity. Here's a simple example code snippet in the assembly language to configure and use timer mode 1 in 8051 microcontroller. Now we'll see the actual program in assembly language for timer 1 operation, timer mode of 1 operation. Move T mode 11H. You are setting timer 0 and timer 1 in mode 1. Because what? 0, 1 lower bits and 0, 1 bit number 4 and 5. So that's why it is 11H. Right? So that means both timer 1 and timer 2 are set in mode 1 by moving 11 to T mod register. Now move TH0FF, initialize the high byte of timer 0. Then move TL0 0FF, initialize the low bytes of timer 0. Then move TH1 0FF, initialize the high byte of timer 1. Move TL1 0FF, initialize the low byte of timer 1. Here you are first initializing the mode of the both timers. Both are working in mode 1. Now you are loading this figure, this value, timer value, to the timer 0. You are loading this timer value in for timer 1. Now set bit TR0. Now here you are starting the timer 0 by setting timer run bit. TR means timer run bit 0. Timer 0 run bit of timer 0, and you are making the to start the timer 0. Now set bit TR1. Here you are setting timer run bit of timer 1 and you are starting timer 1. Now what is, now you are waiting. You are waiting for timer 0 or timer 1 to overflow. Now how you will be waiting? Now here's a code for that. Now you have labeled this as wait. This is a label. And what is this wait? What is the colon? This is called a label. And what is a label? We will see in detail when we will be doing the actual programming. JNB-TF0. Wait until TF0 is set. Wait means unless and you just remain on, go on wait, go back to wait till TF0 becomes 1. Unless and until the TF0 is not becoming 1, be here. And when TF0 becomes 1, then you can go to the next instruction. When TF0 becomes 1, then it will clear TF0 to start the timer again. So this is a delay you are generating here by stopping here. And here you can write some code. When this has, now this has interrupt has occurred. This is one interrupt. You can write some code. You can your code to handle timer 0 overflow or perform other tasks. When the timer flow has overflown and the TF0 has set to 1, that means some interrupt has occurred, you can write the code at that SFR. Also, and similarly, this can be done for timer 1. This is for timer 0. You are waiting at wait here till the timer 1 is overflowing. Once it overflows, you are clearing the timer 1 flag and you are writing some code for timer 1 overflow. That is a interrupt service routine for timer 1 overflow. Repeat the process as needed for both timers. This is what a program for operation of timer 0 and 1 in timer mode 1. In this example, timer 0 and timer 1 are configured in timer mode 1. Then it is started and a program waits for overflow event to occur for each timer. When the TF0 or TF1 is set, it becomes 1. You can perform a specific action or generate a delay as required by your application. Now we'll see what is timer mode 2. This is a figure for timer 2. Now here we are considering a timer 1. This is, you are storing some value in T high byte of the timer, and when it is copied into timer 1, the lower bit of the timer, and TL1 will be incremented, and when it overflows, when the overflow is 1, the value stored in TH1 will be again copied into the TL1. So this is called an auto reload function. The mode 2 operates is in 8-bit mode auto reload timer or counter. The following diagram we are using mode 2 for timer 1. This is a timer 1 and this is a mode 2 operation. This is means whatever delay you want to generate, that will be stored in a high byte. Then timer will be started and this value will be copied in TL1 byte, and TL1 will be only incremented. TH1 will not be incremented. The moment timer overflow occurs, this value will be again reloaded here. This will continue. In this case, every event for counter operation or machine cycle for the timer operation, the TL1 register will be incremented by 1. TL1 as I just told. When the register pair overflows from FF to 00, then the TF1 of the TCON register will be high. Also, TL will be reloaded with the contents of TH1 and start the operation again. So for example, we can say that if the TH1 and TL1 register both are holding F0 hexadecimal and it is in timer mode, then the TF1 will be high after 10H, that is 16 machine cycles. When the clock frequency is say 12 megahertz, this happens after 16 microseconds. Then the following instruction generates an interrupt once every 16 microsecond after timer 1 starts running. If you are storing say F0 value in TH1 and TL1 of timer 1, and if the clock frequency is still 12 megahertz, so after 16 millisecond you will get the timer will start running. It will generate interrupt after every 16 microsecond. Now how it will be done? Move T mode to 0. You are setting a timer mode. How to set timer mode we have already seen many times. Then move TL1, move 0F to the lower byte of timer 1. Move TH1 hash 0F, move F to high byte of timer 1. Then move IE 88H, that means this will enable interrupt enable of timer 1. Then start set B TR1, this will start the timer 1. The above program, the timer 1 is configured as timer mode 2. This is operating in timer mode, that is auto reload. In this case, gate is set equal to 0. Why it is set to 0? Because the timer has to run irrespective of the external pins. So whatever is happening is outside, it will not care for that and it will start running. Then the TL1 and TH1 are loaded with the F0. Then enable the timer 1 interrupt. At last, set the TR1 of TCON register and start the timer. The timer 1 in mode 2 generates the desired baud rate when the serial port is working on mode 1 or 3. When you are using a serial port in mode 1 or mode 3, timer 1 will be used for baud rate. What is baud rate? What is important? We have already discussed in our earlier slides of this lecture. The timer mode 2 is similar to timer mode 0, but it adds auto relate function to timer 0 T0, making it suitable for generating square waveforms and precise timing delay. In this mode, timer 0 counts from 0 to 255 because it is 8-bit, and then automatically reloads its initial value, making it effectively a 9-bit timer. Timer mode 2 of 8051 microcontroller in detail. Timer or counter operation. Timer mode 2 uses timer 0 T0 as the primary timer or counter. Timer 0 is an 8-bit register, but in this mode it is used as an 8-bit timer that counts from 0 to 255. After it reaches to 255, timer 0 is automatically reloaded with its initial value, which is set in timer 0 high bit register T0 and the timer 0 low byte register TL0. We have seen how auto reload is done. Whatever the value is to be reloaded has to be stored in TH0, that is high byte, and this value will be reloaded into low byte when the overflow or interrupt occur. This auto reload feature allowed the timer 0 to repeatedly count from the initial value to 255. This initial value can be anything. So depending how much quantity you want to count, so that much has to be deducted from 255 and that value has to be loaded. Suppose you want to count only 100. So 255 minus 100, that much will be loaded here in TH1. So it will count 100. Because you want to make it 100 counts, that means 255 minus 100 will be 155. So store 155 in TH. Then 155 will become 156, 157, 100 like that, 160 like that. It will go up to 256. That means it will be incremented for only 100 times. And when 255 occurs, it will the overflow will be there, and it will again reload 155 into the TL. So this is, it will repeatedly count 100. Timer mode selection. To select timer mode 2 in the 8051 microcontroller, you need to configure the timer mode control register T mode. T mode is an 8-bit register, and bit 0 and 1, that is T0 M0 and T0 M1, control timer 0 mode. For timer mode 2, set timer 0 T0 M0 to 0 and T0 M1 to M. By setting this, the timer 0 will be set to mode 2 operation. Now clock source. Again we will see what are the different clock source. I will not go in detail. The timer mode 2 uses external clock sources, which is typically provided by the external oscillator circuit or crystal oscillator. The frequency of the external clock source determines the counting speed of the timer 0. You can also select a divided by 12 or divided by 4 option for the external clock using the T0 timer control register. This allows you to further adjust the counting speed. Now overflow and flag. When timer 0 reaches its maximum value, that is 255, and automatically reloads, it does not generate a separate overflow flag as in other timer mode. There is no other flag, because you have to only sell the value in TH1, TH0. Instead the TF0 timer 0 flag, but in the TCON timer control register is set when timer 0 overflows and is automatically cleared when is reloaded. Here what happens, when the TL0 reaches to maximum value, the TF0 will be automatically set to 1, and when it is set to 1, the value stored in TH0 will be automatically loaded into TL1 and the flag will be automatically cleared, and again timer will start. Now interrupts. You can enable or disable timer 0 interrupt in mode 2. If enabled, the timer controller can generate an interrupt request and INT0 when TF0 is set. If you want to attend some interrupt service routine, then you have to enable the interrupt for the timer 0 overflow by setting a proper value in the IE register. When an interrupt occurs, the microcontroller can jump to a predefined interrupt service routine, that is ISR, to handle the overflow event or perform other tasks. Here is a simple example. In assembly language to configure and use a timer mode 2 in 8051 microcontroller. Now move tmod 0 to H. By this command you are setting timer 0 in mode 2. Now why this 02? That will be clear if you refer T mode register, because 02 means you are using 2 bytes, 2 lower bytes of that you are using lower byte for timer 0, and you are setting the value. if you want to work in mode 1, you have to set it 1 0. 1 0 means it will be 2. 1 0, if you are writing, then it becomes digital 2. How could we explain? You are writing 0 1. 0 means, and rest all are 0. That means it will be binary 1 0 means it is hexa 2H. Move TH0 initial value of byte of timer 1. Whatever timer value you want to load, that has to be loaded into high byte of timer 0. Move TL0 initial value. You add both the initial values of the timer for timer frequency. Then set bit TR0 by setting timer run of timer 0. You are starting the timer 0. Wait for timer 0 overflow TF0 to set, and when it is set, your code had to handle. That means if the interrupt has occurred, then it will jump to that ISR and you will be writing some code here to take care of that interrupt. Repeat the process as needed. In this example, you set the timer 0 to operate in timer mode 2. Configure the initial value. Then we have started the timer and wait for an overflow to occur. When the TF0 is set, that means when the interrupt has occurred, you can perform a specific action or generate a square wave with precise timing. Now let us see mode 3. What is the mode 3 of operation? Mode 3 is different for timer 0 and timer 1. When timer 0 is working in mode 3, the TL0 will be used as an 8-bit timer or counter. It will be controlled by the standard timer 0 control bit T0 and INT0 inputs. The TH0 is used as an 8-bit timer but not a counter. It will be used as a timer and it cannot be used as a counter. TH0, that is high byte of timer 0. This is controlled by timer 1 control bit TR. When the TH0, that is high byte of timer 0 overflows from FF to 00, then the timer 1 overflow flag will be set. In the following diagram, we can timer 0 and timer mode 3. This is the diagram of timer mode 3. This is timer 0 input. Timer 0 increment. You are loading some value in timer low byte of timer 0. This will start incrementing. Okay, timer 0 and crystal oscillator, and it is the frequency is being divided by 12, and you are starting timer 1 here, and this will increment high bit of timer 0, and when this timer 0 high byte overflows, then timer 1 flag will be set. Timer 1 overflow flag will be set. When the timer 1 is working in timer mode 3, it simply holds a count but does not run. This timer 1 is only holding the count, it is not running actually. When timer 0 is mode 3, the timer 1 is configured in one of the mode 0, 1 and 2. In this case, the timer 1 cannot interrupt the microcontroller. When the TF1 is used by TH0 timer, the timer 1 is used as a baud rate generator. When you are using a TF1, the timer 1 will be used to generate the baud rate, because TH0 high byte of timer 0 is using this timer 1 over flag to show the overflow. But in this case, timer 1 will be used to generate the baud rate, and it will not be actually taking part in the timing or in the process. The meaning of gate bit in timer 0 and timer 1 for mode 3 is as follows. It controls the running of 8-bit timer counter TH0 as like mode 1, 0, 1 or 2. The running of TH0 is controlled by TR1 bit only. So the gate bit in this mode for timer 0 has no specific role. Here gate is not playing any role because this is being controlled by the timer 1 flag when the TH0 is getting overflown. The mode 3 is present for application requiring an external 8-bit timer or counter. In mode 3 of timer 0, the 8051 has 3 timers. One 8-bit timer by TH0 and another is 8-bit timer or counter by TL0 and one 16-bit timer counter of timer 1. There will be, in mode 3 there will be 3 timers playing the role. That means 8-bit of TH0 timer 0 high byte, another bits of timer 0 that is TL0 byte, and 16-bit of timer 1, all 16-bit of timer 1. This is how 3 timers will be taking part. If timer 0 is mode 3 and timer 1 is working on either 0, 1 or 2, then the run control of the timer 1 is activated when the gate bit is low or INT1 is high. The run control is deactivated when the gate is high and INT1 is low. INT1 is low means interrupt has been cleared. Timer mode 3 is one of the timer mode available in 8051 microcontroller, which provides a combination of features from other timer modes, mode 1 and mode 2. In timer mode 3, timer 0 T0 operates in 8-bit auto reload mode, while timer 1 T1 operates in 16 mode. We have seen that there will be 3 timers will be taking part. This mode is useful when you need different timing resolutions for 2 timers within the same microcontrollers. Timer mode 3 in detail. Key features of timer mode 3. What are the features of timer mode 3? 1. Timer 0 operation 8-bit auto reload. The timer 0, that is T0, is 8-bit timer, meaning it can count from 0 to 255, that is 2 raised to 8 minus 1. After reaching its maximum value of 255, timer 0 automatically reloads with the initial value from the timer 0 high bit register, that is TH0, and the timer 0 low byte register TL0. This auto reload feature simplifies repetitive timing tasks without the need for manual reloading. This is auto reload mode, which we have already discussed in earlier discussion. Then timer 1 operation, that is 16-bit operation. Timer 1 T1 operates as a 16-bit timer. It uses the timer 1 high bit TH1 and timer 1 low byte that is TL1. The timer 1 can count from 0 to 65,535, that is 2 raised to 16 minus 1. Timer 1 is suitable for more extended time intervals and precise timing required, where the timing or counting is required more. That time this timer can be used. Clock sources, as earlier discussion, what are the clock sources? Timer mode 3 allows you to select different clock sources for timer 0 and timer 1 independently. Timer 0 can use either the system clock divided by 12, that is say F system frequency divided by 12, or an external clock source. Timer 1 can use the system clock F system or an external clock source. Overflow and interrupts. Now what are the overflow and interrupts in case of timer mode 3? Timer 0 generates an overflow flag called TF0 of timer 0 overflow flag. When it reaches its maximum value and reloads, timer 1 generates the overflow flag called TF1, not TF0. When it overflows, the timer 1 will be generating timer 1 overflow flag when the reaches its maximum value. When timer 0 is overflowing, TF0 is generating a flag. When timer 1 overflows, TF1 will show the overflow flag. When it reaches to maximum value, you can enable or disable interrupts for TF0 and TF1, allowing you to handle timer overflows via interrupt service routine ISR as needed. How this will be done, interrupt enable, that we will see later. Programming timer mode 3. Now how mode 3 will be programmed? To use timer mode 3 in 8051 microcontroller, follow these steps. First is configure the timer mode control register, that is TMOD, to select the timer mode 3. Then set T0M1 and T0M0 to 0 to configure timer 0 in 8-bit auto reload mode. Set T1M1 and T1M0 to 1 to configure timer 1 in 16-bit mode. Then set the initial values for timer 0, that is TH, that is high bit of timer 0 and low bit of timer 0, and high bit of timer 1 and low bit of timer 1. Choose the clock source for timer 0 and timer 1 based on your application requirement, and start the timers by setting TR0 and TR1 bits. Optionally, enable, if you want, you can enable the interrupts by setting the proper IE register, that is ET0 and ET1 bits. If enabled, you can handle timer overflow through interrupt service routine